Now I'm going to discuss the next part of this topic, relation and functions. Today I'm going to discuss about the relations. So here we are planning how we represent mathematical relations, that regarding the human relations. Like that, here we see some mathematical relations. We have to define in the language of mathematics how relation is defined. And here you try to understand relation is nothing but subset of a non-empty set A to non-empty set B. Once again you see that relation is a subset of that Cartesian product of a non-empty set B to non-empty set A. Both sets you are taking. Once again I say A is a non-empty set and B is another non-empty set. Relation is a subset of Cartesian product of A and B. Relation is a subset of Cartesian product of a non-empty set A and a non-empty set B. So here we have to understand from non-empty set A to non-empty set B we have to take a relation set. A relation is always here denoted by R, but already R is a set of real numbers, but here also we take that R, the relation. The relation R is a subset of Cartesian product of a non-empty set A to non-empty set B. And here you have to see that particularly one thing it is true that all subsets of Cartesian products, all subset of Cartesian product A cross B are called the relations. And here you see that the word subset we are using for relation. Why? Subset that is considered, that is described. Here we have to see that particularly taking two non-empty sets. And basically you can see that the relation R from a non-empty set A to non-empty set B. And here you have to see that a subset of Cartesian product. Once again, finally I say that a relation R, here we are defining, is the subset of, you have to go for particularly the relation from two sets. The relation from two sets. One is set A, another one is set B. A relation, here you see, that is the definition we are giving. A relation means what? A relation R, we are giving the between A and B. A relation R is what? Here we are taking from a non-empty set to non-empty set B is the subset of Cartesian product of A and B. See, R is subset of Cartesian product of A cross B. Once again I to explain that a relation R from a non-empty set A to non-empty set B, and here is the subset of Cartesian product of A and B. Now we say that R means what? Once again, R, a relation R from a set a non-empty set A to non-empty set B is the subset of Cartesian product of A and B. That means R is a subset. You can write like this. R is the subset of Cartesian product. Once again, finally you can consider that, because the heading relations we are saying, you must consider relations here. What? Relations nothing but subsets of Cartesian product. But basically we are defining a relation R, relation small, big R is the symbol, a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product A and B, that we write A cross B. And here we understand that relation is nothing but a subset of Cartesian product. Finish. Once again, a relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product of A and B. That means A cross B. And here you have to understand basically that subset means what? The subset is, here we use the word, a subset is derived. How you can say the subset is, you are told, subset is a relation. And what sense we use that word subset? Subset is derived, and here for describing the relation, subset is derived describing the relationship between what? The first element and the second element, you have to say. So between the first element and the second element, what do you say in that ordered pair? So look here, the word subset is derived for describing the relationship between first element and second element of the ordered pairs of A cross B. Once again, the word subset is derived for describing the relationship between first element and second element of the ordered pairs of Cartesian product. Once again, finally I say that, once again I repeat the relation. A relation R from a non-empty set A to non-empty set B is a subset of Cartesian product A cross B. And here the word subset is derived for describing the relationship between first element and second element of the ordered pairs of the Cartesian product. So here you have to understand that how you take it that the second element and the first element of the ordered pair. And here you understand that second element in the ordered pair is the image of the first element. Suppose if I say the ordered pair AB and this is the image of this, you have to understand basic concept, we take it in the relation. Second element in the ordered pair is the image of the first element. Once again, second element is the image of the, for example, if I say x, y is the image of x. This is the basic concept that you have to understand. And when you say that particularly that second element is called the image of the first element. So I hope you have understood what is the relation. So now one thing it is true that a relation that is denoted by R, that is nothing but from non-empty set A to non-empty set B, is the subset of what? Cartesian product A cross B. Here the word subset is derived for describing the relationship between the first element and second element of the ordered pairs of A cross B. And particularly second element is called the image of the first element, you can say. Now this is all about the definition of relations. Now we go for defining that how we define this relation in another term, and accordingly we can see that, and we have to go for some terms we are defining. Already I told you what is image. Image. What is image? Image is what? In ordered pairs, you see the second element. A second element is the image of the first element. You have to understand. And basically that the set of all first elements in the ordered pairs is nothing but domain of the relation, you can say. What you say? Domain of the relation. And here you have to understand that particularly, and when you see that domain of what? Domain of the relation. So the set of all first elements of the ordered pairs, and particularly in relation R, and from set A to set B is called the domain of the relation R. Once again I say that domain means what? Already you have understood in the relation of nothing but subset. In that subset there must be the ordered pairs. The set of all the first elements of in that ordered pairs, the set of all the first elements of in that ordered pairs is taken as domain of the relation R. See that ordered pairs that we have obtained from set A to set B, and the set of all first elements in the ordered pairs is called what? Domain of the relation. And the images, that means that the images, you see the set of all images means that set of all second elements. You have to see that the set of all second elements, and which are the images of the what elements of the first elements, and that is called the range, you can say. And particularly the set of all second elements in a relation from set A to set B is called the relation. So here you have to see that what is the domain and what is the codomain, that what is the range, I have to explain once again. So R is the relation. First I tell that R is you are having, see this, R is AB, and such that A belongs to A and B belongs to B. This is the relation, you say. And here domain of R, domain, see, domain of the relation R is set of all first elements, and range of R is set of all second elements. See, when you are taking the relation from A to B, the set of all first element, the set of all second elements, and set of all second elements, you can see that it is a range, and basically that they are the perfectly the images of the first elements which you have already taken, and the set of all second elements in the relation R, and from set A to set B is called the range of relation R. And here you see that we can say when set A and set B, the whole set this B is called codomain, we can tell. What you say? The whole set B is called the codomain, and range is what? That is the second elements in the relation. The set of all second element in the relation from set A to set B is called the range. And try to understand, range is always what? Subset of codomain. What do you say? Codomain. Codomain is whole set. The set from the set A to set B, you are telling, that set B is called codomain. Whole domain means whole set B. But range is not whole set B. Range here, the second elements in the relation from set A to set B is called range. But sometimes we tell that the set of all images is also called the range. Images means which are related to the first element. And it doesn't mean that all the elements in the set B are related there. So the whole set is called codomain, and those who are having the relation between set A to set B is called the range. So the range of the relation, domain of the relation, and the codomain, that we can see that whole set, that B is called the codomain. And once again, better you try to understand that basically when you go for the terms domain, don't get the confusion, domain, range, and codomain. Once again, domain is the set of all first elements in a relation from set A to set B. The set of all second element in the relation from set A to set B is called a range. The whole set B is called the codomain. And try to understand that range is always a subset of codomain, and that we can understand with examples later on I am giving you, but basically now you go for understanding the conditions, or you say the definitions of these terms. Once again I repeat, shortcut way I give you the idea. Relation is a subset of Cartesian product, and subset means it is derived for describing the relation between first element and second element of the ordered pairs of the Cartesian product. The set of all first elements is called domain. The set of all second elements is called the range, and the whole set B is called the codomain. And naturally you can understand that range is the subset of codomain. And here you see, either you say domain, or you can say range, or you can say code. All these are the subsets, and those all these are the sets we take. But here subset is a relations of a one set to the another set. So before going to discuss some problems, and I want to tell that some points to be remembered in this case. First of all, you must understand that relation nothing but subset of a Cartesian product, in which first element you have understood, second elements you understood, first elements of the ordered pairs, second element of the ordered pairs, the whole set B. These are the terms we are defining. So basically you can see that a relation may be represented by, particularly how we represent this relation algebraically, either by the roster method or set builder method. Once again I give some points, and after that we go for the problems. What are the first points? I have to tell you the first. A relation may be represented by either the roster method or set builder method. You know that roster form and set builder form, and that is why I tell you either of one method we use to write the relation. Once again, a relation is represented algebraically by number one, roster method, and number two, set builder method. In general, we can say a relation is represented by a roster method or set builder method. And particularly when we represent the relation, totally we can say that an arrow head, you can see that arrow mark we are using, and that is called arrow diagram. We can see that this arrow diagram, this is called arrow diagram. The relation may be represented by that arrow. That means what you call that you have to tell this diagram is called arrow diagram. We can tell what you call, say that arrow diagram. So this arrow diagram is very important to represent. An arrow diagram which I have shown you here is nothing but visual representation. Visual representation. See, visual representation. Very important, the point I have to consider. Once again, you can see that particularly the diagram and basically arrow diagram. An arrow diagram here which I have shown you is what representation, that symbolic representation you can say, and that is called an arrow diagram is a visual representation. Once again, an arrow diagram is a visual representation. Representation of what? The relation. Representation of a relation. So second point, once again I say that an arrow diagram is a visual representation of a relation. Once again, what you say? That is, an arrow diagram is visual representation of a relation. And basically you understand that a relation may be represented by two methods. Already I have told you, one is roster and other one is builder. But an arrow diagram is particularly visual representation of a relation. The 2 point I have explained here. One is arrow diagram. Arrow diagram for what? Visual representation of a relation. That is all right. And when you see in the diagram, and there we can see how the relation is represented. So total number of you see that relations that can be defined from set A to set B. See, once again I tell you, the total relations from the set A to set B, how many? That I want to tell. So that here you can see that the total relations from set A to set B is defined as total number of subsets of Cartesian product A cross B. Once again, the total relations from the set A to set B is defined as the total number of subset of Cartesian product A cross B. Once again you see that total number of relations that can be defined from set A to set B is the number of possible subsets of what you say A cross B. Suppose if you say in number of elements in A is P, number of P is Q, number of what do you say subsets, number of subsets in A cross B is nothing but PQ. So number of n of A, that you know. What is n of A? Number of elements in A, and number of elements in B. Number of elements in A is P, number of elements in B, number of elements in A cross B. A cross B is nothing but ordered pairs only, and that is PQ. So that these number of you see subsets, number of subsets, number of you see that relations also that we can say. And particularly here total number of relations, how we take, and total number of relations you see, and n of A is P, n of K is K, n of P is PQ. So total subsets you can see, total number of subsets you can see the formula 2 raised to PQ. And already I told you 2 raised to n. N is the number of elements. So what is the number of elements here? PQ. And 2, and how many elements are there? And we write the number of subsets. Number of subsets here, number of elements here PQ. Number of subset formula is, see, number of subsets. Number of subsets is formula. Number of subset is nothing but number of relations. Number of relations. And what is the formula? Number of relations is 2 raised to PQ. So you try to understand that number of relations from set A to set B is number of subsets from set A to set B. How do you find the number of subsets from set A to set B? That already you have seen that 2 raised to n. N means the number of elements, and based on that we write the subsets. So number of subsets is equal to number of relations. What is the formula? You have to see how many elements are there in the Cartesian product, for example PQ, and you say that 2 raised to PQ is the number of subsets of the Cartesian product that number of subset is nothing but number of relations. So this is the total part. You can understand that in case of relations. So the last I want to discuss that. So far you have told set A to set B. A to B. Sometimes what happens, A to B only we can tell. The relation from set A to set B we have defined so far. Suppose if you say the relation, the formula you have taken R, the relation R from set A to set B we have defined. Now suppose a relation R from set A to set A only you have to see. Instead of taking B, set A to set B. What I say now here, a relation R from set A to set A, the same set. And here you have to see that is also what particularly it is stated as, defined as, and that we take it that relation on A we can say. What you say? Relation on A we tell. Try to understand on A. Once again I define the relation R from set A to A is stated as, defined as a relation on A. Once again, the relation from set A to set A is stated as relation on A. Sometimes you don't get confused relation on A, because so far you have seen that relation from set A to set B. The relation from set A to set B, so far we have defined. Suppose the relation from set A to set A only means set relation on set A we use. We define it. We state in that fashion. Once again, relation on set A means what? The relation from the set A to set A. So these are the points to be followed while understanding the relation. At the end, I want to repeat once again, and that concludes the end of this relation. What is relation? You have to see that a relation R from set non-empty set A to non-empty set B. Once again, a relation R from a non-empty set A to non-empty set B is a subset of Cartesian product A and B, Cartesian product A cross B. And that subset word derived for describing the relationship between first element and second element of the ordered pairs of the Cartesian product. So here now onwards, relation is nothing but a subset, and particularly the set of all first elements of the ordered pairs is nothing but domain. Domain is nothing but a set. And the set of all first elements is called domain. The set of all second elements is called range. And the whole set B is called the codomain. And finally, that already I told you, the relation can be what? Represented either the roster method or set builder method. And an arrow diagram is a visual representation of a relation, and total number of relations from set A to set B is nothing but total subsets of A cross B. And that formula is there. Total subsets we have to use 2 raised to PQ I told. Why? Number of elements in A is P, number of elements in B is Q, and here you would see total number of elements in the Cartesian product PQ, and hence the total number of subsets is equal to 2 raised to PQ. Thereby total number of relations from set A to set B is 2 raised to PQ. And finally you have to tell that the relation R from set A to set A is stated as relation on A, relation on set A. This is the end of the explanation regarding the relations. Now I have to give problems on this, and hence you can understand here. So that problems. Number 1. First to understand how we go for discussing the problems, and accordingly you can write it. See the first problem. Let A is equal to 1, 2, 3, 4, 5, 6. Define define a relation. Define a relation R from what you say A to A by A to A. It's not but on A, that already I have told you. By R is equal to, see the relation xy such that y is equal to x plus 1. Of course, it is set builder form. And the question is that, what is the question then? Number one, you see that depict what this relation, see this relation using what? An arrow diagram. Already I told you, an arrow diagram is a visual representation of a relation. Second question, write down the domain. Write down the domain and comma range and what? Codomain. What do you say? Codomain. What do you say? Question is, write down the domain, codomain and range. Write down the domain, range and codomain of the relation R. So this is the question now, and try to understand how you are going to work out these two questions. One by one I am explaining. What? A is the set given. The relation is set A to set A only. It is nothing but relation on A. Relation on set A. Okay. Define a relation R from set A to set A is given here. Relation is given. That relation is given in the set builder form. So this is given and you have to calculate this. What is given? Set A is given. And how that relation is there, that is given in the set builder form. The question is, depict what this relation using an arrow diagram. So here you have to show that arrow diagram, how you are going to represent this relation. And basically you have to go for defining by the definition of relation, and accordingly you can say the result. First I want to tell you the question. Depict this relation using arrow diagram. But basically when you write it, this relation is given. Look this. First I want to write. The relation is given. What relation is given? On set A to set A in this set builder. So better you write set builder form to roster form. When you write the roster form, you will understand. And accordingly you can write it. How you understand the roster form. So x, y is 1 more than the x. And the elements are given 1, 2, 3, 4, 5, 6. And accordingly you can write the results here. So the definition you have to write it. What? I write this. First element is 1. Look this. And what is second element? Second element is where? 1. Y is 1 more than x. So 1, this becomes 2. And suppose if it is 2, if it is 3, if it is 3, it becomes 4. Understand? Y is 1 more than the x. Y is 1 more than the x. Y is 1 more than the x. Next what? 4, 5. And next what? You see 5, 6. And next you don't take, because highest maximum is 6. So this is R. So this is a set builder form and I have written in the roster form. By the definition, you have to write first in the roster form and accordingly definition defined in the set builder form. So I hope you understood that particularly the corresponding arrow you have to use it, because already I have told you arrow diagram is visual representation of a relation. That you have to keep it in mind. The corresponding arrow diagram is shown. What you say? The corresponding arrow diagram is shown. How you say that? That I am going to explain. See that once you go for representing arrow diagram, see, this is, I want to tell more clearly that this is set A, you say, and this is also set A, because here you see that A to A. What are the elements in this? 1, 2, 3, 4, 5, 6, and here also 1, 2, 3, 4, 5, 6. So this is also set A and this is also set A. And this relation, depict this relation using an arrow diagram. So try to understand how to represent it arrowgram. So here you can understand that an arrow diagram is shown here. Now I am going to explain. The corresponding arrow diagram is shown that you can understand. So basically you have to go for how you show that arrow diagram. This, what? 1, 2. 1 is the first element and this is second element. 2 is image of 1. 3 is the image of 2. Of course later we define. But when you go for representing an arrow diagram, 1 is represented 2. See, here is 2. Look this, 1 is represented 2 and 2 is represented 3. See, 2 is represented 3 and 3 is represented 4 and 4 is represented 5 and 5 is represented 6. So try to understand an arrow diagram. The corresponding arrow diagram is shown here. The question is, depict this relation using an arrow diagram that I have shown here. And basically this part is, first part is over. And now the second part, what second part? Write down the domain of the relation R. Look this, domain. And already I have told you, it is a set of first elements. First elements is what? First elements you see, which are the first elements, and that you can write. And second elements. So you have to tell that which are the first elements that you can write. Which are the first elements? Don't say that first element means all the elements of set A. First elements what? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. But you don't take 6. 6 is not in the relation. And second one is range. Range is nothing but second element. What? 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. You don't take this one. One is not related to any element. So, and last is codomain is nothing but codomain is the whole set. What you say? This is 1, 2, 3, 4, 5, 6. I hope you understood that how you, domain is also set, range is also set, codomain is also set, and particularly how we write this domain, range, codomain. See once again how an arrow diagram is shown and how to write the domain of the relation R, range of, and particularly you can see range is a subset of codomain. Yes, codomain is not a subset of range, but range is subset of codomain. All the elements of the range set are there in the codomain, so that it is called a subset. So this is the end of the problem which I have taken. I hope you understood an arrow diagram, how we use to show the relation, visual relation that already I have shown you. Now similarly, I go for one diagram. Accordingly, you have to tell the domain, range and codomain of the relation R. So here I write the first problem and that you can understand now. See, what is the problem here? You go for it and accordingly you can understand. So what is the problem number 2 here? See this, very interesting problem. This diagram is given. Look this, one diagram is given. This is the diagram. This is one set, and this is another set is given. What? See, this I am writing the problem, not answer. So here is given that here you see this is 4 and this is 9 and this is 25. And here is given what? And 1, see, 1, 2, 3, 4, 5. Look this, 1, 2, 3, 4, 5. And similarly you can see that, and minus 2, minus 3, minus 4, minus 5. Here also you can see this. And given that particularly relation between the sets, and I take that this set is P, I write this set is Q. See, the question is that in the above figure it is given that what given, I tell that 9 is represented to 3 and 9 is also represented to 3. See, and 4 is represented to 2 and 4 is represented to minus 2 and 5 is represented to 25 and 25 is represented to this. I hope you have understood that what is the case. Now this diagram is given. Question is in the above figure. Look, this is not the answer here. In the above figure, what shows a relation between the sets P and Q. And now you can see that particularly what is the question. Write, question is, now you see, write the relation. Write the relation. What relation you have to see that? Number 1, particularly you have to see that in set builder form. In set builder form. And you can see that second one is in a roster form. In roster form. And again question is that, not completed this question, again the next part question is that what is its domain and range? Question is what is its, what you say, domain and range. See, question mark. Now you have to see the solution. What is the solution for this question now? And particularly you have to see that how we write all these things. You have to look at the figure first. In the above figure shows a relation between P and Q. In the figure given, what is the relation between P and Q? In the above figure shows a relation between the sets P and Q. It is given, you have to see 9, 3 minus 3, 4, 2 minus 2, 25 minus 5 plus 5. It is given. Question is, write the relation. What relation that has shown an arrow diagram, and you have to write in set builder and roster method. So the relation is given, that you have to write in both methods, set builder and also what you say in the roster form. But here you understand that basically how you have to understand and the relation. What relation is given? Look, 9, 3 minus 3, 4, 2 minus 2, 25, 5 minus 5. You have to look and understand. That shows what? What? This 9 is the square of 3 and minus 3. Yes, correct or not? 4 is the square of 2 and minus 2. 25 is the square of 5 and minus 5. This is given in the diagram, arrow diagram that is given, so that you can understand. It is obvious, it is clear that the relation R is what? Particularly first element 9 is the square of 3, 9 is square of minus 3, 4 is square of 2, 4 is square of minus 2. 25 is a square of, what do you say? Y is a square of x. It is clear that if you say this is y and this is x, y is square of x. And here you have to see that whatever you see, that x, if you see these are x, these are x is what? Square of y. 9 is square of 3. 9 is square of 3. Suppose these are the x and these are y, x is a square of y. So that is why we are telling that relation how you can write, and accordingly you can write. So first I want to tell that here you are understanding that x is the square of y. Once again, if you say these are the x and these are the y, 9 is a square of 3, 9 is square of minus 3, x is a square of y. And here also x is a square of y, 25 is also square of y is 5. Now, first is I want to write in set builder form. How you write this in set builder form? And that is the relation. Or we have to write in the set builder form. And in case of set builder form, you have to understand that what x, y relation is ordered pair x, y such that x is a square of what? Square of y. See, x is square of y. Understanding or not in set builder form? X is square of y. See, look, 9 is square of minus 3 and plus 3. So in the set builder form, and it is enough to write, particularly here x belongs to, even if you stop continuing here, x belongs to P and y belongs to Q. X belongs to P set and y belongs to Q. See, in the set builder how you write? xy is such that x is a square of y. And where you understand x belongs to P and y belongs to Q, that is in the set builder form. And similarly, I want to write in the what you say, roster method, roster form. See this, how you write roster form. So this R is equal to, look this roster form. First you see that 9. Look this, 9 is the square of 3. 9 is the square of minus 3. Okay, next you say 4 is square of 2. 4 is square of minus 2. And similarly 25. 25 is square of 5. And 25 is square of minus 5. So this is in the roster form. And try to understand how we write all these in the roster form. And next question is what? And basically you can write, the question is, what do you say, write its domain and range. What is domain and what is range? Already I have told you domain of this relation is nothing but what? It is nothing but set of all first elements. Which are the first elements you see? 9, 4, 25. See what you say, domain is 9, 4, 25. Yes. Once again write 4, 9 increasing order. 4, 9, 25. 4, 9, 25 are the first elements of the ordered pairs in this relation. And the range is what you say, second elements. Second element means what? Here you see second elements. You see that particularly starting least one is minus 2, minus 3 and minus 5, 2, 3, 5. See, these are the second elements. And the second elements is a set of second elements is called the range. So basically you have to understand that you write it. This is the way how you can understand the range. Range is set of second elements. So this is the end of this question. How we write the set builder form, how we write the roster form, how you write the domain, how you write the range. So here I want to discuss that. And finally, one more problem that you may go for, that is the last problem I want to discuss. That is the end of this part. One more problem I want to discuss. Why? That is the point which you have to remember. See, first I write the problem and go through it, analyze it, and start writing the answer, required answer. Basically, you must know domain, range, codomain, definition of a relation, and also writing the relation in set builder as well as roster problem. See this last problem number 3. What? Let A is equal to 1, 2 and B is equal to 3, 4. Find the number of, see the question, find the number of relations. Find the number of relations from A to B. See that how to write the number of relations. And basically you know the number of relations. The number of subsets, how many subsets are there that you have to calculate. And when you go for A and B, relation means ordered pair. First you find out the A cross B is how much. Now, what is A cross B? You have to write all the relation. A cross B is how much you have to. That is particularly is find the number of relation. R is A cross B. And A cross B is total relations we are going to calculate. And that you have to take the Cartesian product, and accordingly you have to see that how to write the Cartesian product. First you write A cross B, we have to multiply. You see 1 3 1 3 1 4, next 2 3 and 2 4. See 1 2 3 4, 4 elements in the Cartesian product. See here you are understanding that n of A is how much? 2. And n of B is how much? 2. N of A cross B is how much? 4. See that number of elements in the A cross B is 4. And here you have to write that number of, here you see the number of elements 4 that you have understood, but now you have to see the number of relations. So now the number of relations from A to B is equal to, see, number of relations is nothing but number of subsets. Number of subsets formula is 2 raised to PQ. PQ is the number of elements. Here number of elements in A cross B is how much? 2 raised to 4. See, number of subsets from set A to set B is equal to 2 raised to 4. But number of subset is nothing but number of relation from set. This is 2 raised to 4. How you have got this 2 raised to 4? You have got number of elements in the Cartesian product. So this is, you can see 2 raised to 4 is 2 to 4, 8. It is nothing but 16. So there are 16 relations you can see from the set A to set B. And even if you keep the answer in this form is okay, 2 raised to 4. Number of subsets, nothing but number of relations. So this is the end of the topic relations. And here I have done some problems. Similarly, you can take the textbook in which the exercise 2.2 you have to see, you have to work out all the problems. Even though I am sending you the answers for all the questions which you can see, 2.2, and the last part of this topic I take it functions in the next class. Thank you.